that day you came in, we were talking about girl stuff just to make you uncomfortable. Just so you know. Okay, so today we're going to talk about right triangle stuff, which should maybe be a little bit review of geometry for you. And then we're going to relate this back to the whole circle and angles and talk about why we put triangles in with our circles here. But if you have a right triangle, right, very important, it's only true for right triangles. Call one of these other angles theta. It doesn't matter which one. I'm going to call this one theta, but whichever angle you're talking about, like, it's important that that one's labeled theta, not the other one. Remember that you can find the value of it by using the ratio of the sides. And maybe you remember from geometry, you learned this lovely little phrase, SOHCAHTOA, because there are these functions, sine, cosine, and tangent, that you can set up using this, right? And so if this is theta, do you agree that this would be the opposite side of theta? Side opposite that angle, so I'm going to call that opposite for now. The longest side of the triangle, the side across from the right angle, is always called the hypotenuse. And then the side next to the angle, but not the hypotenuse, is called the adjacent side. Adjacent means next to. If I say look at the person adjacent to you, it would be the person next to you, not the person opposite you. And those would be the labels if theta's down here. Do you agree with me? If theta's up here, then the opposite side is changed. Theta's up here, this is now the opposite side, and this is the adjacent side. I never knew that people got that. Like, some people always thought that the opposite side was always that side over there. So I've learned through the years that to make sure I say that. But the sine of theta would be the ratio of the opposite side over the hypotenuse. So we say opposite over hypotenuse. Or that's where the SO comes from. Sine is opposite over hypotenuse. Cosine is another function, and cosine's ratio for that angle is equal to the adjacent side over the hypotenuse. Or that's where the CAH comes from, SOHCAHTOA. Cosine is adjacent over hypotenuse. And tangent of that angle is equal to the opposite over the adjacent. Vague memories of this from geometry class? And wherever theta is, these ratios are the same, but the side would change of which side's the opposite, which side's hypotenuse. In geometry, did you learn anything? But like, did you learn other functions with signs? Hypotenuse wouldn't change. You're right. Sorry, the other sides would change. Each of these trig functions also have a reciprocal. So I don't think you've learned these before, but I might be wrong. Did you ever learn this function? This is the reciprocal of sine, and it's CFC, but I'm going to write it underneath so that you can see what the real word is. This stands for cosecant. There are actually real words for these too. Sine has an E on the end. Cosine is really spelled like this. Tangent is really spelled like this. It really, really annoys me when people say cos. It's not cos, it's cosine. We just shorten it to write it. Cosecant is the reciprocal of sine, so it's really easy to remember. If sine is opposite over hypotenuse, what would the reciprocal of that be? Hypotenuse over the opposite, right? It's just a reciprocal. Cosine also has a reciprocal, and it's secant. How about that to confuse you? SEC. My whole life, I've always felt like they did this just to make people hate math even more. Because wouldn't it make sense if cosine went with cosecant? Because they both have co in front of them? Like this one's secant, and this one's cosecant. Why do they do that? So I always remember it's the opposite of the way it should be. Now I've just confused you all, haven't I? And it's the reciprocal of this, which is hypotenuse. Oh, I just stepped on my cord. Over adjacent. And tangent also has a reciprocal, and it's the easiest one not to mix up because it has the word tangent in it. It's cotangent. And cotangent, reciprocal, flip it over, would be adjacent over opposite. We have SOHCAHTOA for sine, cosine, and tangent. We don't have a cutesy phrase for this one. It doesn't really work out so nice if you try to make one. So you got CHOSHACHAO. Right? That would be if you took each of these letters like you do for SOHCAHTOA. That's nothing. That's not that exciting to do. I got nothing there. So I always just say no SOHCAHTOA, and then you just flip them over to get the other ones, right? Choshakao. SOHCAHTOA. Yes, you have. Oh. Okay. When I was in school, there was something about apples. The A stood for apples. That's all I remember. I don't know. Obviously, it didn't help me because I don't remember. So we're just going to go back and do a little bit of geometry because it's important as we go to our unit circle. There's always triangle people and unit circle people, and I show you both methods, and then I'll let you pick which one you like better. I'm kind of a triangle person. It is hot in here. Find all 6 trig functions. Notice they labeled theta for us. There's a problem, though. They only give us 2 sides of the triangle. How can we find the 3rd side of the triangle? If it's a right triangle. Oh, Pythagorean theorem. Right? Remember, if you have a lovely right triangle, because Pythagorean theorem, we're going to do over and over again. Because it's math class, and that's our job. Make you work it out. Some of these you'll actually hopefully start to recognize. This is a Pythagorean triple. It works out really nice. That maybe you know what the number is. But make sure you put the 13 in the hypotenuse spot. So it'd be like 5 squared plus b squared equals 13 squared. What would that be? 169 minus 25, which would be 144. And that's b squared, so what would you do to solve that? Take the square root of it, and the square root of 144 would be 12. Yes? 5, 12, 13. That's a Pythagorean triple. 3, 4, 5. That's the other one. If you know all 3 sides, we're just going to plug them in, right? Sine of theta. Really important that you put of the angle there. If you just write sine equals, that's mathematically incorrect because you're not telling me what you're taking the sine of. So it's really important you put whatever angle they give you. Maybe they'll use theta, maybe they'll use alpha, whatever's there. Make sure you write that. And sine is opposite over hypotenuse, which would just be opposite over hypotenuse, 5 over 13. You with me on this? Cosine of theta. So it's adjacent over hypotenuse. So that's just 12 over 13. And tangent is opposite over adjacent, which would be 5 over 12. Follow me on this? We're also going to find the reciprocal functions. And again, it's not that bad to do because if you know these 3, do you know the reciprocal functions as well? You just need to make sure you label them correctly. So it's good practice. The reciprocal of sine is cosecant. CSC. CSC. So if sine is 5 over 13, what's cosecant going to be? 13 over 5. I don't even ever look at my triangle there. We could. It's hypotenuse over opposite. But I always just find the 3, and then I flip them over. The reciprocal of cosine is secant of theta, and it's going to be 13 over 12. And the reciprocal function of tangent is cotangent, and it's going to be 12 over 5. That's all 6 functions. All right. It's like dating it. Right? What's another? What if they give you this instead of a little triangle? If they give you sine, what do you know right away? You know that this is the opposite side and this is the adjacent side in the triangle, right?
No, H.
This is the opposite side and this is the hypotenuse because it's sine equals opposite over hypotenuse. At least you noticed. Which means, could you make a little triangle and could you label it? And then it pretty much turned into the problem that we just did. Again, it doesn't matter which angle that you label theta. It matters that wherever you label theta, you label the rest of the triangle the same. So I don't care whether you call this theta up here or this theta down here. It just matters that you type in the numbers correctly. So type in. If I call this theta, then this becomes my opposite side, which is 2, and this is my adjacent side. If you put theta up here, then you're going to have 2 here and 3 here. I promise we'll get the same answers. So can you find what the hypotenuse is? Oh my gosh, why did I do that?
I don't know.
Logan, you freeze here. Just kidding. Because it's hypotenuse. Not adjacent. And that's okay. We like square roots. We're going to learn to love square roots. Well, you're going to learn to either just hate them a lot more or learn to deal with them. Square roots aren't bad. We can leave a square root, especially if it's not a perfect square. If there's not a perfect square in it, we just leave it alone. So if we're going to solve this, to agree, we would get 4 plus something squared equals 9. 9 minus 4 would be 5. So that other side would be the square root of 5. Don't give me a decimal. Leave it as a square root of 5. Yes. Because the square root of 5 doesn't ever stop. So if you just give me a decimal to a couple places, that's not really the square root of 5. Yes, sir. What did I get? C? I just maybe use A there for adjacent side. But you have to put 3, because this is sine, it's opposite over hypotenuse, right? You have to put 3 as the longest side. So when you're doing Pythagorean theorem, the 9 has to be over on the other side, right? Because that's what I did at first too. I labeled it wrong, and I would have got the square root of 13. Now we can just list these all out. We already have sine, so we don't really need to work it out. But could I find cosine of theta? And what would cosine be? Not opposite, right? CAA. Adjacent over hypotenuse, right? So I think that would be the square root of 5 over 3. What about tangent? Opposite over adjacent is 2 over the square root of 5. We normally leave square roots in the bottom of our fractions. We're not going to. Really easy. And once you do this a few times, you won't even actually show the work because you'll just know what's going to happen. But to get this out of the bottom, do you agree? I'm just going to multiply the top and the bottom by the square root of 5 because that would make that a perfect square. So on the top, I would get 2 square root of 5 And on the bottom, what would I get? The square root of 25, which is just 5. Shortcut for simplifying a radical, if it's just one radical on the bottom, the radical just moves to the top, and the radical comes out of the bottom every time. So you do need to simplify that. What else do I need? We need all 5 trig functions, right? So what are my other trig functions? Cosecant, and that's the reciprocal of which one? Sine. So if sine was 2/3, what's cosecant? 3/2. What else do I have? SEC. Or secant. I really don't like SEC. And here's where you want to, oh yeah, this one's not going to be so nice either. Square root of 5 over 3, I'm going to flip it over, right? So I'm going to get 3 over the square root of 5. And I got to get that square root out. So I'd get 3 square root of 5 over 5. Cotangent. Don't say cot. Because it just drives me crazy. Say the function. We're in precalculus. When people aren't in math and they've never taken precalculus or geometry and they say sin and they say cos and they say tan, I kind of give them a little credit because they haven't taken the class and they don't know. But I hate it. Drive me crazy. Cotangent. One thing we could do is we could take our simplified answer and we could flip it over and then simplify it again, yes? Let's go back to what we did before we simplified it. What if I just took the unsimplified answer? Would that work out nicely and not have to do any work to it? So could I flip this over instead of flipping this over? And get you the same answer, it's just less work. So it's up to you on how you want to do it. You could just flip this over and you get the square root of 5 over 2. If you flip this over and then you simplify it again, guess what you're going to get? The square root of 5 over 2 when you work it all out. So my advice is go back to the part before you got it out of the denominator so you don't have to do it again. Questions about that? There is not a button on your calculator for that, but we'll talk about how to do that later on. No. Are we good with this, though? This is not so bad, right? Fine and stuff. We're going to skip this one and go straight to my special angle triangles. How does this relate back to the circle? Well, there are certain angles that we like to deal with in a circle, and they correspond directly to some special triangles that you learned about in geometry. I know it's been a few years, which is why I'm going over it again for you. But there are 2 special right triangles that we use a lot, and that correspond directly to the angles that we use the most when we go to the circle. I'm going to do it in terms of degrees today, but then we'll eventually change that over to radians. But one of them is a 30, 60, 90 triangle. So the shortest side should be across from the shortest angle. So that would make this 30 degrees and this 60 degrees. And in a lovely 30, 60, 90 triangle, there's a ratio that always works out nicely, and that is if the smallest side is 1, the hypotenuse is always double that, so that's 2, which makes this side, if you do Pythagorean theorem, the square root of 3. 1, 2, square root of 3. And if you know that, then you can list all the trig functions from that, right? So 30, 60, 90, 1, 2, square root of 3 are some ratios that probably we should maybe learn. The other lovely triangle that we like to deal with right triangles is an isosceles triangle. Remember what isosceles means? 2 of the sides are the same. So if 2 of the sides are the same, that means these 2 angles are also the same, which would make that 45 degrees in each one. 45, 45, 90. And the great thing about this one is the sides are 1 and 1, and the hypotenuse is the square root of 2 when you do that. Why am I using 1? Because we're going to talk about that unit circle with the radius being 1 unit, so that's where this 1 is coming from. there's this big crazy unit circle that you can learn and you can memorize and you can use it all the time, or you can learn these two triangles and you can use them all the time. So I like to teach you both. I teach you the triangles first, and then I teach you the unit circle. And really, you can kind of use both. I kind of use triangles more, but I go back and forth. We could list all 6 trig functions out now, right? We could actually do this for all 3 of these acute angles, 30 degrees, 60 degrees, and 45 degrees. So let's just kind of go through here and do it real quick. We're only going to do sine, cosine, and tangent. I trust you could do the reciprocals as well. So use my little triangle here, and let's do the sine of 30 degrees, the cosine of 30 degrees, and the tangent of 30 degrees. These are just special angles that we use a lot. Like eventually, not right now because it's the first day, eventually I'm going to be able to say, give me the sine of 30 degrees, or in radians, the sine of pi 6, and you're going to hopefully know it without having to draw a triangle. Well, you know, we'll see. But sine is opposite over hypotenuse. Would you agree that's just 1/2? Cosine of 30 degrees is adjacent over hypotenuse. Adjacent over hypotenuse would be the square root of 3 over 2. And tangent would be, which would be or square root of 3 over 3, because I'm just going to move that up, and then the bottom becomes 3. Let's just do all these angles, 45 and 60. The nice thing about 45 degrees is the sides are both 1 and 1, so you're going to see that that works out really nice here, except for it's a square root, right? What would the sine of 45 degrees be? One over the square root of 2, which I'm going to simplify that as the square root of 2 over 2. What would the cosine of 45 degrees be? The same thing, because the adjacent and the opposite side are the same, so it's still going to be 1 over the square root of 2, which I'm going to go ahead and just simplify as square root of 2 over 2. So that's why 45 degrees is a nice one, because the sine and the cosine are the same. And even better, what does the tangent turn out to be? Because it's just opposite over adjacent, or 1 over 1, which is 1. So 45 degrees is a nice one, probably one of the easiest ones to memorize. 60 degrees, we're back over here in our 30, 60, 90, and you should kind of see something happening here. If I take the sine of this, that's opposite over hypotenuse, and I think you should get the square root of 3 over 2. Cosine of 60 degrees is adjacent over hypotenuse, which is 1/2. You notice that these switch on the 30 and the 60. It was 1/2 square root of 3 over 2. Now it's square root of 3 over 2, 1/2. That's not a coincidence. What about tangent? Tangent is opposite over adjacent, square root of 3 over 1, or just the square root of 3. Again, if you know these two triangles, you're going to be able to do everything that's in this big unit circle that some people get a little overwhelmed with. So today, some of these say give the exact value of this angle. You can draw a triangle. You can use this to help you. I've given you some answers to your homework. The only other thing we're really doing today is practicing using our calculator, because there are some things that don't work out very nicely that we can't give lovely little answers to, or that we don't want to draw a triangle with, and that's where we can use our calculators. Who needs a calculator? semester quiz, you will definitely have to use a calculator because it's important that you're able to do this. Notice the difference between this problem and the other ones we've been doing. The other ones we didn't know, we just did sine of theta, cosine of theta, and we were finding what ratio it was. Now they give us the angle and they want us to take the sine of it. Really, really important that you're in the right mode, and you're going to need to change mode. So the first thing that you need to learn where the button is on your calculator is the mode button. For my calculators, it's the button right next to the second button where it says DRG. If you click that button, you should see at the very bottom of the screen it changes. Like right now, it should say degrees down there, DEG. If you hit that button, the next option is RAD, which is radians. Number one thing, make sure your calculator is in the right mode depending on what problem you're doing. How do you know what mode you need to be in? The problem itself. This is in degrees, so you want to make sure you're in degree mode. Okay, so on a test, I will remind you before the test, check the mode of your calculator as you're doing these problems, but I'm telling you, every year people miss a lot of problems because they're in the wrong mode. So make sure in your degree mode, and all you're going to do is you're going to type that in. On my calculators, there's a sine button, and you hit sine, and then you type it in. Depending on the calculator you have, you might have to hit the number and then sine. But I just want to check and make sure we all get the same answer here. In degrees, if we go to 4 decimal places, you should get 0.2815. Anyone need help with that? Sine, cosine, and tangent aren't that bad to do because they have a button there for them. Justin already pointed out, is there a button on my calculator to do the other ones? And there's not, because you can use what you know about the answer there. Second thing I want to point out about number 2, is there a degree symbol here? There's not a degree symbol, so this means that you must be in radian mode. If you do it in degree mode, your answer's wrong. So really important that you pay attention to that. So before we do anything, change your calculator to radians, and at the bottom, it should say RAD, or some calculators just have an R there for radians. So there is no cosecant button. But what do we know? Cosecant is the reciprocal of what function? Sine, right? So, what? No. But that's if it was an angle. Like if it said, I see what you're saying. If it said cosecant of theta equals 3, right? You could just flip it over and say that means sine of theta equals 1/3. Do you agree with me on that? But that's not what this is saying. This is telling you what the angle measure is, so you can't just flip it over, but it's kind of the same idea. If cosecant of theta 3 is the same as saying 1/sine of 3. This is what you can type on your calculator. Okay, so you don't just flip the 3 over, you move the whole thing to the bottom and you make it the reciprocal function. So that's for cosecant, secant, and tangent. So if you see cosecant, then you move it to the bottom and make it sine. So it's 1 divided by sine of 3, and that's 3 radians. And again, these are not going to be very pretty numbers here. We're going to go to 4 decimal places, and I got 7.0862 if I'm rounding to 4 decimal places. Did you get that? Are you in radians? 1 divided by sine of 3. Right? You can't just hit sine of 3. You have to put the 1 divided by to show that it's cosecant. Other questions about that? Using your calculator, very, very important. I think that's it for today. This is 4-2 day 1. We have one more day of 4-2. The plan is on Friday I'm going to give you a worksheet over what we've done so far. And I want to have like a real quiz next week, probably Monday of next week. Not just a homework quiz to kind of test and see where we are on this stuff. So just kind of keep that in mind as we're going forward. If you don't have a sine calculator with these buttons on it at home. If you have a computer, then you have access to that. Because one, you can just Google scientific calculator, and there's one that comes up pretty much that looks like this. You can also go to accessories on your computer, and there's a calculator that has scientific mode on it. If you have a smartphone, I know my iPhone, I can turn my calculator sideways, and it has sine, cosine, and tangent on it. So you should have access to one somewhere, hopefully.
I think I hit something like on my iPhone, but like if you turn my iPhone, the screen doesn't turn over. I think I did.
Like I think you can lock the screen so that it won't. I don't know. Go to settings.
Unlock.